Okay, so picking up where we left off, we just kind of discussed the multiplicity, which just represents the exponent of the factors. And so if it's odd, it's going to cross the graph. If it's even, it touches or basically bounces off. And the three that we're going to run into mostly are going to be powers of one, two, and three. And basically, it's going to look like the shape of if you had just a straight line for power of one, and then power of two, it kind of has that parabola shape where we bounce off. And then power of three, it's going to have more of that cubic shape to the graph where we cross the x-axis. So now what we're going to do is we're going to look at these equations, find the x-intercepts, list the multiplicity, and then determine whether they cross or touch. And so looking at this equation right here, let's see. So we have an x squared, we have x plus 2 to the power of 3, and then x minus 5 to the power of 1. And we'll just go in order that they appear. And so the the 0, the solution to this would be 0. If you were to let x equal 0, it would cause this whole thing to just zero out, right? And so that's my solution for that one. That's my 0. And then the multiplicity is referring to the exponent, the k. So that's going to be a 2. And if it's even, it touches and turns around or bounces off. You might see that it says cuts through it or bounces off. So you might see different language when you're doing your homework. So that's for the first one. Then the second one, the solution to this one, the 0 for this one would be x equals -2, because if you plug in -2, this would turn into a 0, and it would knock everything out, right? So that's going to be the 0 here. Then the k refers to the exponent, which is a 3. And since it's odd, it's going to cross. So odds cross. If it's odd, it's going to cross. If it's even, it's going to touch. Okay, and we're referring to this value right here. Okay, then the last one, the solution to this one would be x equals 5, because if you plug in 5, 5 minus 5 is 0. It's one of our zeros right here. Now its exponent wasn't listed, but it's an understood 1, and so since it's odd, it's going to cross. Okay, my next example is going to be more the same, except that it's not in factored form. We have to go ahead and factor this. And then once we factor it, it should be very similar to example A. Okay, so what we're going to do here first, so if you notice, I can factor out a GCF, which in this case is going to be x, and that's going to leave me with x squared minus 6x plus 9. And then we can factor that right there. So let's see, that's going to factor into, so let's see, what multiplies to give me 9 but adds -6? That would be x minus 3 and x minus 3. Now, if you have common factors, you want to go ahead and bring them together. So we're going to want to go ahead and rewrite this as x times x minus 3 squared. So now we can see that multiplicity value right there. Okay, so for my first one, this should be pretty easy. That first one's going to be the 0. The solution's going to be 0. And my multiplicity is going to be that understood 1. So my x, when x equals 0, that's one of my zeros. And then that multiplicity is going to be a 1. So once again, if it's odd, it's going to cross. Okay. And then the next one right here, that's going to be at x equals 3. And that multiplicity is going to be a 2. So when x equals 3, that's one of my x-intercepts, and its multiplicity is a 2. So it's actually going to touch or basically bounce off the x-axis. And so now what we'll do is we're going to look at some pictures of graphs and determine their multiplicity by looking at the shape of how it looks. So from the given graphs, determine the zeros and their multiplicity. So I'm just going to go from left to right. So you can see right here, we have a 0 right there at -2, and its multiplicity is going to be a 1. So remember, if it kind of just cuts through like a straight line, it's just going to be a multiplicity of 1. Now, our next 0 is over here. It looks like it's at 4, and it does cut through, right? It cuts through, which means it's going to be odd multiplicity, but this one, it has that cubic shape to it. It doesn't just go straight through it like the first one did. It curves in and out of it. It's got that kind of cubic shape to it. So that means that that multiplicity is power of 3. Okay. Then our next example right here, we have another one at -2. And that multiplicity is going to be 1 again because it just cuts right through it, right? It's just basically like a straight line cuts through the x-axis. And then here at 1, we bounce off, and it's got that parabola shape to it, right? It's got that parabola shape, so that's going to be a multiplicity of 2. And then the last one, it does the same thing. It's going to come and bounce off right there at 4. We're going to bounce off at 4. So once again, that's going to have a multiplicity of 2. So just to kind of take a little more of an in-depth look at this now, I don't know that this is exactly what the equation would be because there's other things that can affect it. But looking at example A, this would be something like y equals x plus 2 to a power of 1. That's right here because -2 would zero this out, and the multiplicity is a 1, right? And then the second one right here would be at x minus 4, because if I plug in 4, right, that would give me a 0. Now that multiplicity would be a 3 right there. Now, like I said, this probably isn't exactly the equation for this, but it's something close to this right here. Because right there you can see where the zero's at, and the multiplicity is just referring to the power of that factor for that 0. Okay, and so same thing with example B right here. This would be something like y equals x plus 2, because -2 would be the solution. The multiplicity would be 1, so it'd be power of 1. And then the next one would be x minus 1, because 1 would cause this to zero out. Now that would be a power of 2 because of the multiplicity. And then the last one would be x minus 4, and then also multiplicity of 2. Now, once again, this probably isn't the exact equation because there might be a number in front or something like that. But just kind of, once again, to give you a little bit better idea of what's going on. So this is another piece of the puzzle. So we started with in behavior, trying to figure out what happens on the extreme right and left, right? What's happening? Do we go up? Do we go down, right? The x-intercepts are to help us kind of figure out the roller coaster ride. What happens in the middle? And so that's what we just got done doing. And so now it's going to be time to piece this all together and come up with some graphs. So this is exactly how it's going to look on your homework. I wanted to make sure I have examples that will look like what you can expect from the homework. So right here are the directions. Use the leading coefficient test to determine the end behavior. So we'll start with end behavior of the graph. Then we want to determine the x-intercepts of G and the multiplicity of each of those intercepts. Also describe the behavior of the graph at each x-intercept. If the third x-intercept does not exist, then enter D and E when appropriate. Okay, so here we are. So here's our first one. And on your homework, you can expect something pretty similar to this. And so first thing we have to do is the leading coefficient test. So this is the leading coefficient. So since it's positive, we're going to go up to the right. And then since we have an odd exponent, that means we're going to do the opposite effect to the left. So we're going to go down to the left. So let's see, falls to the left. Yes, that's what this is saying. Since it's odd, we're going to have the opposite effect to the left. So it is definitely going to fall to the left. Let me give it a little sketch. So there's going to be some ups and downs. We're going to go up to the right, down to the left. So falls to the left and falls to the right. Nope, it's going to rise to the right. So let's see, falls to the left, rises to the right. So there we go. This is the one we're looking for right there. And so that was determined by the leading coefficient test. Because it was positive, we go up to the right. Because the power was odd, we go down to the left. Now we're going to find the x-intercepts and determine what it's going to look like here in the middle. So that's the next part. So the first thing you want to do is find those x-intercepts. So we're going to take that equation 2x cubed minus 6x squared minus 32x plus 96 and set that equal to 0 because we want to find the x-intercepts. All right. So whenever you see four terms, you should probably think factor by grouping. But before I do that, what I do notice is there is a GCF I could factor out of this, and that would be a 2. And so that'll help make my numbers a little bit smaller. Now, I don't want to, if I'm just finding the x-intercepts, that's fine. I could just divide everything by 2. But I kind of want to hang on to that 2 because it does affect how the graph looks. So I'm not actually going to just divide everything by 2. You could, but if you're going to use this equation to help you find some additional points later, it's probably best that we don't do that. Okay, so now I'm ready to go. Now that I factored out that 2, I'm going to focus on finding the GCF. I'm going to focus on factor by grouping. So on the first 2 and the second 2. So I don't want to forget about that 2 that got factored out. So here I can pull out an x squared, and that will leave me with an x minus 3. And then right here, I need to factor something out to where I can be left with an x minus 3 also. And so in this case, it's going to be a negative 16. And so this would become x minus 3. So take a moment, just make sure you see everything's the same here. The blue is the same as the black, which is the same as the red right here. I'm just manipulating this to get it into a factored form. Okay, and whenever you see four terms, you should always think factor by grouping. And I could have done the grouping from the beginning, but I noticed I could factor out that 2, and it just makes the numbers a little bit easier to work with. So what I'm going to factor out next to go with that 2 is going to be the x minus 3 right here. That's going to get factored out next to the 2. So let's see, we're going to end up having 2 times x minus 3, and then what's left behind in those brackets, and I'll use brackets so we can kind of distinguish them, is the x squared minus 16 right there, the x squared minus 16. So this is getting factored out with the 2 right there. Okay, I'm almost done, except that I have the difference of 2 squares right there, so I can factor that a little bit further. And so I'm going to end up with, let's see, 2 times x minus 3, and then this is going to factor into x plus 4, x minus 4, and then equals 0. And so now it's all factored. And so I have three x-intercepts. So the first one here would be positive 3, this one would be a negative 4, and then this one would be a positive 4. And so be careful, make sure you read these directions, but the way they want us to put this in is it wants us to enter the multiplicity of the least x-intercept. What they mean is like the smallest value here, which is going to be negative 4. So think of a number line, okay? So on the number line, negative 4 would be here, then we'd have 3, and then we'd have 4. So the least x-intercept is going to be the negative 4 right here. And then we need to go ahead and put the multiplicity. So the least of the x-intercepts is that x equals negative 4, and its multiplicity is a 1. And by the way, all the multiplicities are going to be 1. Then it says the multiplicity of the greatest x-intercept at x equals, now that would be positive 4. So now the greatest one is over here at 4. Once again, it has a multiplicity of 1. And then the multiplicity of the other. So if there's a third one, which there is, it's right there at 3. And that also has a multiplicity of 1. And so if we only had 2 x-intercepts, then you would use that D does not exist, D and E. Okay, so now they're going to ask a couple more pieces of information, basically how it's going to look. So at the x-intercept, x equals, And so the least one would be -4 again. The graph, it's going to have something like bounces or cuts through the graph or whatever. And so we're going to say cuts through. Okay, I just looked it up. It actually is going to say crosses. So it's going to be either touches or crosses. So I just want to make sure I'm consistent here. So it crosses the x-axis at -4. And then for the greatest x-intercept, the largest one, which was +4, it also crosses. They're all going to cross. So it crosses the x-intercept. And then the other one, we did have a third one, which was 3. And for that one, it also crosses the x-axis. All right, so then they ask us to determine the y-intercept. Well, that's fairly easy because by definition, just let x equal 0. And so if you let x equal 0, you're only going to be left with that 96 right there. You're only left with 96. So if we let x equal 0, y is going to be 96 right there. Then they ask us to determine whether the graph of G is even, odd, or neither. Most of the time it's going to be neither, but we could see even and odd. And so that was covered in Unit 2. And the easiest way to think about this is if it's even, all the powers have to be even. So that's not true. And for it to be odd, all the powers have to be odd, and there can't be a constant. There can't be an extra value that doesn't have a variable. And so, like I said, most of these are going to fall into the neither category. So it's real simple. If they're not all even, they're not all odd. Right away, you know if all your powers are neither even or odd, then you don't even need to think any further about it. So that one's going to be neither. Like I said, it's not going to come up very often, but it will a little bit. Okay, so now it says use the information from above to graph the function. And so what I'm going to do here is I'm going to take this equation with me, and this is going to help me over here and with the behavior. Now, when you're doing your homework, it's actually going to be a multiple choice to pick the graph, so that should make your life a little bit easier. But let me gather this information, and we'll go down there and graph it. Okay, so I grabbed a copy of the information I need to help me graph this. So I know it's going to fall to the left and rise to the right. So that's important. And then I know my x-intercept, so I'm going to go ahead and plot those real quick. So let's see, -1, 2, 3, 4. So we'll put one of my x-intercepts right here. And let's see, then to the right, let's see, 1, 2, 3, 4. And we're just going to kind of do a rough sketch. It doesn't need to be perfect. We want it to be accurate, but it doesn't have to be exactly perfect. Let me do that. Okay, so you know the end behavior falls to the left and rises to the right. So what we're going to do here is it's going to rise to the right, fall to the left, and we know that all of them are going to cross almost like a straight line. And then I also know that my y-intercept's somewhere up at 96, right? So I'm going to go pretty high up there. So we know it's going to go pretty high up, and we can kind of scale this and just do it in sets of like 25 or something. So 25, 50, 75, and 100. And you'll notice that on your homework that that's how they'll do it. They'll scale the graphs that you'll be choosing from. And so I know I'm somewhere up here at like 96, right? And then so I cut through almost like a straight line, but it's curved. And I'll come up. Remember, we don't want any sharp turns. So I come up, hit there, and I'm going to come back down. And I'm probably going to dip down just a little bit. I'm not sure exactly how much, but something like this, and then come back up right there. And so you might be thinking, well, what about that parabola shape? Well, it's not at the x-axis. So they're all kind of like straight lines where I cross the x-axis right there. So everything should be good. And like I said, on the homework, you're going to have multiple choice. You're going to pick between 4 different graphs. And so as long as you have the x-intercepts and you have the right behavior that's taking place, and then go ahead and put your y-intercept there and make a little rough sketch, you should be in good shape and you'll be all right. So I'm going to go ahead and stop here for part 2, and we'll pick up on the next example in part 3.